In Lesson 8, the students learned about distance on the coordinate plane. Okay, and this is definitely a challenging topic, but one that I think after you look at it for a while, it starts to make sense, okay? The first 2 points they want us to find the distance of on your problem set are 7, 2, and negative 4, 2. So I have on my board a coordinate plane, and we're going to plot them to talk about them first. Okay, so the first point we have to plot is 7 over 7 up 2. And the next one, I believe, was negative 4, 2. Okay, so I'm going to start at the origin. I'm going to go over to negative 4 on my x-axis and up 2 on my y. And they want us to find the distance between these 2 points. Okay, so just by looking on the coordinate plane, I can tell the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These 2 points are 11 spaces away from each other. However, on the New York State math exam, okay, we are not sure that a coordinate plane is going to be provided, okay? So there is another way to do that without a coordinate plane, and I'm going to teach that to you right now, okay? I always line them up on top of each other, 7, 2, okay, negative 4, 2. Okay, these 2 points have the same y-axis, or y-coordinate. So I cross them out, and I look at the 2 x-coordinates, okay? 7 and negative 4 have what I call different signs. Different ends with a T, and I tell the students it also looks like a plus sign, okay? When the signs are different, it means they're on opposite sides of the x-axis. One is in quadrant 1, the other is in quadrant 2. So in order to find the distance between these 2 points, students have to add the absolute value of both of the numbers to find the total distance. The absolute value of 7 is 7. 7 is 7 units away from 0. The absolute value of negative 4 is positive 4. It's 4 units away from 0. So the distance between these 2 points is 11. Okay? I'm going to go to a different one. I'm not going to do all the ones on these homeworks, because if you cross out the ones they have in common, the ones that are remaining are all different signs. Okay? So with all of these, you would add them. When they're different signs, you add them. I'm going to give you a different one. I'm going to ask you, or show you, how to find the distance between points when they no longer have different signs, but they have the same sign. So I'm going to go back to my coordinate plane. And my points that I wanted were 5, 2, and 5, 6. So I'm going to start at the origin. I'm going to go over 5 up 2. I'm going to start at the origin again. I'm going to go over 5 up 6. This is different because they both had the same x coordinate. This is a vertical line, okay, and we are going to find the difference or the distance between these 2 points, okay? This is different because these 2 points are in the same quadrant, okay? They are not crossing quadrants. So these 2 points are 1, 2, 3, 4 units away. That makes a little bit difference when you are doing it this way. Again, I line them up on top of each other. I cross out the coordinate. They have the same. These 2 have the same sign. Same starts with the letter S. Same means subtract. Okay, you do not have to pass different coordinates. We're going to subtract the absolute values of these. Absolute value of 6 is 6. Absolute value of 2 is 2. 6 minus 2 gives us a distance of 4. Okay, I'm going to do 3 examples with you without the coordinate plane. Okay, finding the distance between these 2 points. Students should cross out the coordinate that they have in common. Okay, And then they should look and see if the signs of the remaining coordinate are the same or they're different. In this case, they're different. So you are going to add the absolute values of the coordinates. The distance from these 2 points is 9. Okay, another one. Okay, we're going to cross out the ones that they have the same. 6 and 5 are left. Okay, these two are both positive. They are the same. So we are going to subtract their absolute value. These two are 1 unit away. Final one. Sorry about that. -2. Okay. You cross out the coordinate. They have the same. You look at the ones that are remaining. These two have different signs. So I'm going to take the absolute value of both the coordinates and I'm going to add it together. Okay, and this is the distance in the coordinate plane. Now they can do a lot of stuff with distance. So in the homework, they gave a couple of questions that were a little different, still based on the distance. So I do want to go over those two with you. Okay, number 2. Sarah and Jamal were learning partners in math class and were working independently. They each started at the point -2, 5. Okay, and moved 3 units vertically in the plane. Each student arrived at a different endpoint. How is this possible? Okay, I'm going to circle 3 units and I'm going to circle the word vertically. Vertically means up or down, okay? The quadrant or the coordinate that would be up and down would be the y coordinate, okay? So Sarah and Jamal have to go 3 units vertically from 5. They could go 3 units up or they could go 3 units down. So since we're remaining vertically, you could keep the x-axis or x coordinate and you could add 3 to +5 and that would be +8. That would be 3 units up. However, you could also move 3 units down from 5. 5 minus 3 would give us this coordinate. These are both correct because they're both 3 units away from each other. Okay, so then they get even a little more tricky. It's a very tricky problem, and I'm going to go over this again tomorrow in class with my students, because I think this is a lot to think about, okay? The length of a line segment is 13 units. One endpoint of the line segment is -3, 7. Find 4 points that could be the other endpoints of the line segment. So if you thought about it, -3, 7 is right here. So you want to find a point 13 units away in this direction, 13 points away in this direction, 13 points away in this direction, and 13 points away in this direction. And as you can see, no coordinate plane is provided. So the students really have to understand distance, okay? So I'm going to make 4 blank coordinate pairs, and I'm going to think about this. If I'm at the point -3, 7, I can move vertically. That means I would keep the x-axis the same, and the vertical one that would change would be the y. I could add 13 units to the number 7. 7 plus 13 is 20. Okay? However, I could also move 13 units down from 7. If you took 13 away from 7, you would take away these 7 and you would go down another 6, which would have us in the negative region. Okay? So that would be -3, -6, because 6 plus 7 gives you a value of 13, their absolute values, okay? So now, not only could you go vertically up or down, but the points could be horizontally away from each other, which means the x's would change and the y's would stay the same. So if I was at -3, 7, I could go over more negative. So I would add 13 more in the negative direction to -3. That would get me to -16, okay? Or I could go 13 in the more positive direction, which means you would take those -3 away, and you would be at the y-axis, and then you would add another 10 positives for a total of 13 altogether, and that would be at +10. We will be doing more of this in lesson 9. But hopefully this is just a brief overlook of lesson 8.